Hi, welcome. This is Carlos, and today's theme is CAN. I'll talk a little bit about me, and I have a background as an automobile technician, and it never ceases to amaze me the complexity of those systems. Even more, it makes me very curious about the ECU. This is from the Electronic Central Unit, and how it communicates with other computers in the automobile. Uh, so in this video we'll have a quick overview of CAN, and this is the standard for the vehicle communication, even though there is used for different systems. So the contents, we're going to discuss CAN concepts, principal features, frames, components, and processes. In another video, the STM32F4 is used to transmit CAN frames. Slides preliminaries, and we're going to talk about interruptions. Before beginning with CAN, let's know this kind of concepts. First, the host processor uses interruptions to catch CAN frames. Those interruptions alert the host processor when CAN frames are available. In this case, interruptions are better than pulling. If you don't know what's an interruption is a signal from a device attached to the computer or any program software that tells the interrupt service routine to stop the program and decide what to do next. The system uses an interrupt vector to catch interruptions, stop them, and the principal feature of the interrupt vector is to solve them by priority. For example, in the STM32F4 we have fixed interruptions and settable interruptions. The fixed interruptions has a negative value, and those interruptions are, for example, the reset and fail device. In the CAN controller we have something called FIFO or FIFO. The FIFO terms refers to a queue that the CAN controller used to store and dispatch verified frames that were verified. So features, let's begin with the principal features of CAN. CAN means controller area network. CAN was developed in 1983 by Bosch, the company, and is used extensively in automobiles. CAN board is composed by 3 pins, and there are CAN high, CAN low, and ground. The ground can be omitted and is only required to handle various problems such as open circuit or short lines. CAN high and CAN low are 180 degrees of the phase, as the diagram shows. This diagram. Well, it's high. When the signal have different, when both signals are close, between them, the difference is near 0 volts. This is called recessive state or logic 1. When the signal is like a mirror, this way, and they have a difference in voltage, is called dominant state or logic 0. If we have 11 recessive bits, means that we have a bus, an idle bus. So it's turn to talk about frames. A frame is a message that is transmit and received through the CAN network. A frame is composed of 4 principal parts. The first is the ID or identifier extension, that it's 1 bit length. If ID is set to 0, means that the ID is 11 bits length. When I refer with the last ID, means the ID we use to prioritize bits. This type of ID is called a standard CAN. If the ID is set to 1, then the ID is 29 bits length. This type of ID is called extensive CAN. Okay. The second part is the ID that sets priority among frames. If 2 or more CAN frames are put in the bus at the same time, then the highest priority will be processed first. The other will be delayed until the next bus idle time. The third part is the DLC, or data length code. It is 4 bits length and determines the data bytes from 0 bytes to 8 bytes. And the last part is the data byte that can be anything and goes from 0 to 8 bytes length. We have components, and now the components start with the ECU. CAN is a multi-master serial bus for connecting electronic control units. The ECU can be displayed as a node, and 2 nodes are required on the CAN network to communicate. There is 2 wires bus to communicate nodes. Those 2 wires are twisted and have some resistors in the limits. They might be half the watt resistor. That's it. Referring above nodes, there are controllers nodes. We have also transceivers nodes. Well, actually, the controller nodes might have a transceiver part integrated. A CAN controller with valid frames housed in the FIFO that is part of the CAN controller. It notifies the host processor that the data is available in the FIFO. CAN controller filter can be programmed. This is a feature that is in the CAN controller. Can be programmed to ignore certain CAN frames. Also, the CAN controller is programmed by creating a configuration in each register. The transceiver transmit and receive frames. When transmit a frame, we create this frame and wait for a trigger. When we receive a frame, we send a AC key slot if that frame has no error. And the AC key slot is an acknowledgement used to show to the entire network that a valid CAN frame was received. All nodes must operate at the same frequency. The speed it depends from 10 kilobytes per second to 1 megabyte per second. Processes transmitting. Okay, I'll give you an example of how a CAN frame is set to the network from a controller. First, the controller built a frame in one of its TX mailbox. Second, the message is passed to the parallel serial converter. This is required because some processors are parallel and CAN is a serial bus. Then the frame passes to the I/O pins and wait for a trigger. Then the signal is triggered, and any node that is idle will receive frames from the network. The frame with the highest priority is dispatched first. Then the transmitter node waits for ACK field that determines the acceptance of the frame. And if that frame was accepted, then this node goes idle. If the frame wasn't accepted, the transmitter resets it again for a long time. Then is received. All nodes that aren't transmitting they are in the receptive mode. So a frame is received in the node when a node is in the receptive mode, and frame is received in the node's I/O pins. And if the frame has no error, then ACK is sent, and if the frame has error, then it's ignored. If the frame had any error, it passes to the serial to parallel converter to allow the controller handle this frame. The frame passes to the frame passes to the acceptance filter. If it's rejected, then it's just discarded. We don't care about it anymore. If the frame was accepted, then it's stored to one of the controller's FIFO. Then the host processor is alerted by interruption, and that the frame is in the controller FIFO. And the next part is that the host, the processor, determines what to do with the frame. I took those frames, those references to do this slide. So hope you enjoy it, and see you next time.